Okay, for chapter 12, again, two sections we're going to do. First one today, and we'll get to the other one a little bit later. 12.1 is matrices, and again, this is not Keanu and the Matrix and, jumping in and out of different realities and all this other stuff. This is just the number part of it that you would have to kind of go through some things on this one. And we're going to do two things in 12.1. We're going to do addition and subtraction. Before we get to that part of it, we've got to just make sure that y'all know the basics of what it is. And the way they're going to symbolize a matrix is they'll just give you use capital letters for these, and then you'll have just a block of numbers that's set off by a square bracket of parentheses on this. And when you talk about, and we'll put actual numbers in these here in a second, but just to kind of get you an idea of what we're talking about for this first part. They're just talking about, like, in general terms, if you use capital A for the matrix, every item inside of it's going to have a little a. And the numbers at the bottom, the subscripts, those are basically like location trackers. The first number is going to tell you the row that it's in. So this would be like the third row. The second number is going to tell you the column. So if we were looking at something like, with capital A being the matrix that we're talking about, this would be the element that's at location 1, 1. It's in the first row. It's in the first column. This would be the first row in the second column. So they're basically just telling you like a location when it comes down to it. If we did B the same way, it would be B1, 1, B1, 2, B2, 1, and B2, 2. Okay, and for everything that's in 12.1, everything we're going to do is really pretty straightforward, because if it talks about doing addition, if you have to do matrix A plus matrix B, it's going to be really what it sounds like. You're going to take the location that's in 1, 1 position here, and you're going to add it to the one that's in the 1, 1 position here. So you're going to add items that's in the same position or same location, ever how you want to call it there. And we'll actually put some numbers on this here in just a second. So when we're doing this one, again, we'll actually put the numbers on it. We're going to take A in the 1, 1 position, add it to B in the 1, 1 position. And that would be the answer that would basically be in your top left corner there. If you kind of look at it in the top right corner, we're going to do this A1, 2 and the B1, 2. So basically it'll be something like that. Okay, and subtraction would work the same way. We would just take out the plus and make it a minus over here. So if we were doing subtraction, again, we won't write that one out, but it would basically be the same thing. If it was A minus B, every one of these would be A minus B when we go through this part. Okay, so let's give you one where you got some actual numbers on it so you can see, what it is it's going to look like. So for matrix A, we'll do negative 12, 24, negative 3, 5, and negative 1, 10. And for B, we'll make it negative 3, 1, 2, negative 4, and negative 1, 5. Okay, and addition is pretty straightforward. There's not really anything tricky that comes about when we're doing addition on these. And I'm going to show you this part of it just because it's the first problem that we'll do. If there's any problems we do after this, you don't necessarily have to do this. But for this one, when we're adding these together, it's negative 12 plus negative 3. Made that a little too tight, I think. Let's just start this over because I messed that one up. Okay, so that'll be what we'll do. We'll take the top left-hand corner, add those two numbers together, and then the top right-hand corner will be 25 plus or 24 plus 1. Okay, going down the next one, it's -3 plus 2. Next column over is going to be 5 plus -4. And going to the last row, the first number we've got -1 plus -1. And in the last column on the bottom row, it's 10 plus 5. Okay. And all you'll do from there is just, add up the numbers. It's -12 plus -3. That's a -15. 24 plus 1 is 25. -3 plus 2 is -1. 5 plus -4 is 1. -1 plus -1 is -2. And then 10 plus 5 is 15. Okay, so addition sounds like what it is. It's just taking one corner at a time, one piece, one location at a time, and adding that into the matrix that has another location, and you add those together. The catch with these, if you're adding and subtracting, is you have to have matrices the same size to be able to add them or subtract them. So if you've got one that's, this one, if you were to count this one, you've got 3 rows and 2 columns. This would be a 3 by 2 matrix. Same thing with this one. It's a 3 by 2 matrix. So again, and when we're just like when you do the locations, we do the rows first and columns second. If you're describing a matrix, you do the same thing. You tell me how many rows you have first, and then how many columns you have second. So when you're describing these, it's always rows first and columns second. So as long as they're the same size, you can add up any matrices that's the same size. If they're different sizes, you can't add them together, because if this one only had 2 rows and 2 columns, well then all of a sudden these two don't have anything to match up to, so they have to be the same size before you can add them and subtract them. In plural of matrix is matrices. So that's, matrices is that part. So matrices must be the same size to add or subtract. Usually that's not a big deal, but occasionally in some of the homework and some of the problems, they may give you 2 matrices that are different sizes and ask you if you can add these together. And I think all these, they'll give you a option that's not possible, so that, if they do have to throw one in there like that, then that would be the case. Okay, the one you've got to kind of be careful of is subtraction. Just because with subtraction, you're always throwing a negative inside a problem, that's going to throw things off. So what we'll do is we'll go back to this same 2 matrices we got here, but this time we're going to do subtraction instead of doing addition. Okay, so this time we'll take those same 2 matrices we've got and we'll make it A minus B. And this is one I would say that you probably, now if it's addition, you can just pretty much go, it's -12 plus -3, write down the number and be okay with it. Subtraction, I would say make sure to write these down, because sometimes, because it's -12 minus -3, sometimes people will get in a hurry and they'll forget and leave out a negative, or they'll forget to do the minus negative and make it a positive. So with subtraction, I would say take your time and actually write these out for this part of it. Next one here, we've got 24 minus 1. -3 minus 2. 5 minus -4. -1 minus -1. And then 10 minus 5. Okay, now, again, if you think you can keep up with it in your head, that's fine. But usually with subtraction, from what I've seen over the years of doing this, when people can do addition in their head, because it's pretty straightforward. subtraction with that extra minus in the sign in the middle, sometimes people kind of get a little off track. So I would say write that one out just to be on the safe side. So it's -12 minus -3. That's really -12 plus 3. So it would be -9. 24 minus 1, that's straightforward. That's just 23. -3 minus 2 is -5. 5 minus -4 is really 5 plus 4, which would be 9. -1 minus -1 is really -1 plus 1, which would be 0. And then 10 minus 5 would be 5. Okay. And again, if 0 is a number, don't leave it blank. Sometimes people say, oh, it's 0. I just leave it blank. No. In the matrices, you have to leave that 0 in there. If not, it doesn't make it be the right size. Now you've got one piece that's missing here. So anytime you get a 0 number, just make sure to leave that part of it in there. Okay. Now here's where they'll kind of change things up just a little bit when we're going through these. They're going to have you solve a matrix equation. But really, when you're solving a matrix equation the way they set up here, you're still just going to add or subtract matrices together to figure out what the answer is going to be. And they'll do something like this. They'll tell you that, let's say that B is equal to 1, 6, -1. (2, 6, 1) and -1, -2, 4. And then matrix C, we'll go with 2, 0, 0, -1, -3, 6, and then 2, 3, -1. Okay, so they'll define out what your matrices are that you're working with. And then below that, they'll give you basically a little equation to have you solve. That basically for this part, they may ask you to find that if A minus B is equal to C, then that's all right. Tell me what A is. Well, they may say solve for A. That may be another option they do. And basically on that part of it is that you've got this equation that's here. You're basically trying to solve for A. So to get A by itself, you would just add B to both sides. So A would be equal to C plus B, which means, okay, to find out what A is, we just got to take matrix C, add it to matrix B, and then we've got what we're looking for A. Okay, so now, and then we'll go back through and start adding these parts together. In any of these equations that you'll do in section 1, that's all you're going to do. You're going to either wind up adding these two matrices together, or once you solve it, you'll have to wind up going back and subtracting, either B minus C or C minus B. So everything we do in section 1, again, it's all adding and subtracting when it comes down to it. To do C plus B, well, if it's addition, then we can just pretty much just add these two together. And this is one just to save us a little bit of time. We'll just kind of add it together here. So it's 1 plus 2, which is 3. It's 6 plus 0, which is 6. It's -1 plus 0, which is -1. Okay, and then we'll go into the second row. So now it's 2 plus -1, which would be 1. It's 6 plus -3, which is really 6 minus 3, which is 3. And then it's 1 plus 6, which would make it 7. Okay, and then we go to the last row, and then we'll start working from there. It's -1 plus 2, which would be 1. It's -2 plus 3. which is 1. And that's 4 plus negative 1, which is 4 minus 1, which would just be 3. Okay, and to me, addition's really straightforward, really easy, because again, it's just doing this number plus this number. The hardest thing you might have to do is, again, you may have a couple of negatives, you may have to add or subtract, but there's nothing tricky about doing addition. It's to take the two numbers, you put them together, and that's it. With subtractions, sometimes if you're doing the minus negatives, you've got to change the signs and work through it. So that's probably the hardest part, is working through some subtraction ones on these. Okay, and then the last thing that they'll throw at you with section 1 here, where we're working on solving equations, is they're going to ask you to find some unknown values. And this is normally where they'll give you two matrices that are equal to each other, so that you'd have something like this. You'd have x plus 3, negative 2, maybe y minus 1, and x plus 1. And in the other matrix on the right-hand side, maybe it's 9, it's a z, 2y plus 5, and then 7. Okay, and this one is really pretty straightforward too. That for these problems, if it gives you two equations or two matrices and just says find the unknown values, you're just going to take it one piece at a time, and you're going to set whatever the location is that you have here equal to this location, and then you just solve that equation. So x plus 3 is equal to 9, which means that x would have to equal 6. Okay. And some equations go a little faster than others. It just depends on the numbers. When you go to the next part, we've got a negative 2 that's here in the second column equal to the z that's here. Well, if you do negative 2 equals z, that's it. It's negative z is equal to negative 2. So there you go. That one's already done without having to do anything at all to it. And then on the bottom row, you've got a y minus 1 that's here and the 2y plus 5 that's here. So we'll set those two equal to find out what's going on. Okay, subtract the y, move it over here. And then from there, get the y by itself, so we'll subtract 5 from both sides. So y would equal negative 6. Okay, and if there's only 3 variables, once you solve for those 3 variables, you're okay. And some people go, well, what about the x that was in the bottom right-hand corner? Well, you already know that x is equal to 6. So if x is equal to 6, x can equal 6 and something else in the same matrix. So if you did go back and solve this one, you should get the exact same answer, which we do. So once you got it solved here, you don't have to turn around and resolve it back over here. So basically, you kind of get to pick which one looks easiest to you. If you think this looks easier than that, then you can go back and solve that. Okay. Oh, and here's one last little thing. And this is not really a topic; it's more of just something that may pop across when you're going through these. The last little thing that they talk about with matrix addition and matrix subtraction is they may talk about a zero matrix. That a zero matrix is what it sounds like. It's a matrix with all zeros. Sometimes it's also called the addition identity matrix. Or they may say it's the identity matrix of addition or something like that. And it's basically kind of going back to all those properties that you used to learn about back when you were doing commutative property and associative property, and they had the identity property of multiplication. They had the identity property of addition. This one's kind of that same thing. This is the identity matrix of addition, or the addition identity matrix, whatever how you want to call it there. It's just basically saying, and this is something that you would dig into kind of later on when they start talking about different things. So just realize if they talk about a zero matrix, that's the same thing as the identity matrix of addition or the addition identity matrix, or how you want to call it there.